Hello students, today we are going to learn lesson 8 Metallurgy. The topics we are going to cover today are physical properties of metals, physical properties of non-metals, chemical properties of metals, reactivity series of metals, chemical properties of non-metals and corrosion of metals. The substances around us are in the form of some or the other elements or their compounds. In the beginning, elements were classified in accordance with their chemical and physical properties into metals, non-metals and metalloids, and these are even in use today. You have studied their characteristics last year. We are going to get more information about them in this lesson. Physical properties of metals. Metals exist mainly in solid state, but there are some exceptions. The metals, namely mercury and gallium, exist in liquid state at room temperature. Metals possess luster. The metallic luster goes on decreasing due to exposure to atmospheric oxygen and moisture and also in the presence of some reactive gases. Metals possess the property of ductility. That means they can be easily drawn into wires. Metals are malleable, that is, they can be beaten into sheets, and this property is called malleability of metals. Metals are good conductors of heat. Silver, copper and aluminium are the best conductors of heat. Metals are good conductors of electricity. Lead is an exception, which is neither a good conductor of heat nor a good conductor of electricity. Generally, all metals are hard. However, the alkali metals from group 1 such as lithium, sodium and potassium are exceptions. These metals can be cut with knife as they are very soft. Metals have high melting and boiling points. For example, tungsten metal has the highest melting point, that is 3422 degrees Celsius. On the contrary, the melting and boiling point of metals such as sodium, potassium, mercury, gallium are very low. A sound is produced when certain metals are struck. This is called sonority. These metals are known as sonorous metals. Physical properties of non-metals. When properties of non-metals are considered, it is found that some non-metals are in the solid state while some are in the gaseous state. Exception is the non-metal bromine, which exists in liquid state. Non-metals do not possess luster, but iodine is the exception as its crystals are shiny. Non-metals are not hard. Diamond, which is an allotrope of carbon, is the exception. Diamond is the hardest natural substance. Non-metals have low melting and boiling points. But there is an exception. The solid non-metals carbon and boron melt at high temperature. Non-metals are bad conductors of electricity and heat. Graphite, an allotrope of carbon, is an exception as it is a good conductor of electricity. Non-metals are neither ductile nor malleable, that is, you can't even draw them into wires or beat them into sheets. Now let us see the chemical properties of metals. Metals are reactive. They lose electrons easily and become positively charged ions. That is why metals are called electropositive elements. To begin with, we will see the reaction of metals with oxygen. Metals combine with oxygen on heating in air and metal oxides are formed. Sodium and potassium are very reactive metals. Sodium metal combines with oxygen in the air even at room temperature and forms sodium oxide. You see the reaction, sodium plus oxygen giving sodium oxide. But on exposure to air, sodium readily catches fire. Therefore, to prevent accident in the laboratory or elsewhere, it is kept in kerosene. Oxides of some metals are soluble in water. They react with water to form alkali. See the reaction. Sodium oxide with water gives sodium hydroxide. Here you can see the burning of magnesium ribbon in the air. When magnesium burns in the air, it forms magnesium oxide. And this magnesium oxide, when it reacts with water, it forms an alkali called magnesium hydroxide. Just see the reaction. Magnesium plus oxygen giving magnesium oxide, and magnesium oxide plus water giving magnesium hydroxide. Here you can see in the diagram reaction of metal with water. A metal sample is reacted with the glass wool soaked in water, and during this reaction hydrogen gas is given up. Sodium and potassium metals react rapidly and vigorously with water and liberate hydrogen gas. See the reaction, sodium plus water giving sodium hydroxide plus hydrogen gas, as well as heat is given out during this reaction. Potassium plus water gives potassium hydroxide plus hydrogen gas and heat is liberated. On the other hand, calcium reacts with water slowly and less vigorously, and the hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles, and the metal floats on water. See the reaction, calcium plus water giving calcium hydroxide plus hydrogen gas. The metals aluminium, iron and zinc do not react with cold or hot water, but they react with steam to form their oxides, and hydrogen gas is released in this reaction. Just look at the first reaction, aluminium plus steam giving aluminium oxide and hydrogen gas. Iron plus steam giving iron oxide plus hydrogen gas. Zinc plus steam giving zinc oxide plus hydrogen gas. Reaction of metals with acids. Here you can see the experiment conducted of reaction of zinc granules with dilute HCl. And during this reaction, hydrogen gas is given out. When samples of aluminium, magnesium, iron or zinc are treated with dilute sulfuric or hydrochloric acid, sulfate or chloride salts of metals are formed. Hydrogen gas is liberated in this reaction, and the reactivity of these metals can be indicated by the following sequence. That is, magnesium is more reactive than aluminium, and aluminium is more reactive than zinc, and zinc is more reactive than iron. Now let us look at the reaction here. Magnesium, when it reacts with hydrochloric acid, gives magnesium chloride plus hydrogen gas. When aluminium reacts with hydrochloric acid, aluminium chloride is formed with the liberation of hydrogen gas. When iron reacts with hydrochloric acid, ferrous chloride plus hydrogen gas is given up. And zinc plus HCl gives zinc chloride plus hydrogen gas. Now let us see the reaction of metals with nitric acid. Metals react with nitric acid to form nitrate salts. Depending on the concentration of nitric acid, various oxides of nitrogen are formed. Just see the first reaction. Copper plus concentrated nitric acid gives copper nitrate plus nitrogen dioxide plus water. And copper plus dilute nitric acid gives copper nitrate plus nitrogen monoxide plus water. Now let us learn something about aqua regia. Aqua regia is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. Aqua regia is a very highly corrosive and fuming liquid, and it is one of the reagents in which noble metals like gold and platinum can dissolve. Reaction of metals with salts of other metals. Just look at the experiment here. Here you have taken a clean copper wire and a clean iron nail, and the copper wire is dipped in ferrous sulfate solution and the iron nail in copper sulfate solution. Just keep on observing them at fixed interval of time. You will see that copper coating is formed on the iron nail. This is because iron has displaced copper from copper sulfate. It means that metallic iron is more reactive than metallic copper. We have seen that the activity of all the metal is not the same. However, the reagents oxygen, water, acids are not useful to determine the relative reactivities of all the metals, as all the metals do not react with them. The displacement reaction of metals with solutions of salts of other metals serve this purpose. So if a metal A displaces another metal B from the solution of its salt, then it means that the metal A is more reactive than the metal B. Scientists have developed the reactivity series by doing many experiments of displacement reaction. The arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Metals are divided into the following groups according to their reactivity. First, the highly reactive metals, second, the moderately reactive metals, and third, the less reactive metals. The metals which are placed at the top of the reactivity series are very reactive. They are never found in the nature as free elements. For example, sodium, potassium, calcium. The metals in the middle of the reactivity series, such as iron, zinc, lead, they are moderately reactive. And the metals which are placed at the bottom of the reactivity series are least reactive. They occur in the free state. For example, gold, silver, copper. Reaction of metals with non-metals. Noble gases like helium, neon, argon, they do not take part in chemical reactions. But if you look into the electronic configuration of some metals and non-metals, it will be seen that the driving force behind a reaction is to attain the electronic configuration of nearest noble gas with complete octave. And metals do this by losing the electrons, while non-metals do this by gaining electrons. Here you can see the sodium metal gives away one electron, while the non-metal chlorine takes up one electron, and an ionic compound of sodium chloride is formed. Similarly, magnesium and potassium also forms ionic compounds, magnesium chloride and potassium chloride respectively. Chemical properties of non-metals. Non-metals are a collection of elements having less similarity in physical and chemical properties. Non-metals are also called electronegative elements as they form negatively charged ions by accepting electrons. Now let us see some chemical reactions of non-metals. Reactions of non-metals with oxygen. Non-metals combine with oxygen to form acidic oxides. In some cases, neutral oxides are formed. Just see the reaction. Carbon plus oxygen on complete combustion gives carbon dioxide, which is an acidic oxide. And carbon plus oxygen on partial combustion gives carbon monoxide, which is a neutral oxide. Sulfur plus oxygen on combustion gives sulfur dioxide, which is an acidic oxide. Reaction of non-metals with water. Generally, non-metals do not react with water, except the halogens. For example, chlorine on dissolving in water gives hypochlorous acid. Just look at the reaction. Chlorine plus water giving hypochlorous acid plus HCl. Reaction of dilute acids with non-metals. Generally, non-metals do not react with dilute acids. Halogens are exception to this. For example, chlorine reacts with dilute hydrobromic acid to form bromine and HCl. See the reaction. Chlorine plus dilute hydrobromic acid giving HCl and bromine. Reaction of non-metals with hydrogen. Non-metals react with hydrogen under certain conditions such as proper temperature, pressure, use of catalyst, etc. Sulfur plus hydrogen gives hydrogen sulfide, and nitrogen plus hydrogen gives ammonia. Corrosion of metals. First, let us see what is corrosion. The process in which a metal is destroyed gradually by the action of air, moisture, or a chemical like an acid on its surface is called corrosion. Iron reacts with moist air and a deposit of reddish substance Fe2O3H2O is formed on it, and this substance is called rust. Carbon dioxide in moist air reacts with the surface of copper vessels. Copper loses its luster due to the formation of greenish layer of copper carbonate on its surface. This is called patination of copper. Here you can see the copper-cladded Statue of Liberty made 300 years ago has turned green. It is due to the greenish layer of copper carbonate on its surface. On exposure to air, silver articles turn blackish after some time. This is because of the layer of silver sulfide, that is Ag2S, formed by the reaction of silver with hydrogen sulfide in air. By oxidation of aluminium, a thin layer of aluminium oxide forms on it. Prevention of corrosion. Various methods are used to protect metals from corrosion. Special attention is made in almost all the methods so that iron does not rust. We can lower the rate of process of rusting of iron. Corrosion of metals can be stopped by keeping metals isolated from a direct contact with air. The prevention of corrosion can be achieved by various ways. Some of these methods are as follows. To fix a layer of some substance on the metal surface so that the contact of the metal with moisture and oxygen in the air is prevented and no reaction would occur between them. Second, to prevent corrosion of metals by applying a layer of paint, oil, grease or varnish on their surface. For example, corrosion of iron can be prevented by this method. We cannot protect the articles permanently from rusting by painting them. The method of painting is suitable for short time. If there is a scratch on the paint on the surface of the article and if a small surface of the metal comes in contact with air, the process of rusting starts below the layer of the paint. Corrosion can be prevented by putting a layer of non-corrodable metal on a corrodable metal. This can be done in many ways like galvanizing, tinning, anodization, electroplating, alloying. We shall learn about them in detail. Galvanizing. In this method, a thin layer of zinc is applied to prevent corrosion of iron or steel. For example, shining iron nails, pins, etc. In this method, corrosion of zinc occurs first because zinc is more electropositive than iron. After a few rainy seasons, the zinc layer goes away and the inner iron gets exposed, and then the iron starts rusting. The galvanizing process consists of mainly the three steps, that is the surface preparation, galvanizing and inspection. The metal which has to be galvanized must be properly prepared prior to be immersed in the bath of molten zinc. Tinning. In this method, a layer of molten tin is deposited on metal. We call this as kaolin. A greenish layer forms on the surface of a copper or brass vessel. This greenish layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all such damages. Anodization. In this method, metals like copper, aluminium are coated with a thin and strong layer of their oxide by means of electrolysis. For this, the copper or aluminium article is used as anode. As this oxide layer is strong and uniform all over the surface, it is useful for prevention of corrosion of metal. For example, when aluminium is anodized, the thin layer of aluminium oxide is formed. It obstructs the contact of aluminium with oxygen and water. This prevents further oxidation. This protection can be further increased by making the oxide layer thicker during the anodization. Metals possess luster. The metallic luster goes on decreasing due to exposure to atmospheric oxygen and moisture and also in the presence of some reactive gases. Alloying. First let us see what is an alloy. The homogeneous mixture formed by mixing a metal with other metals or non-metals in certain proportion is called an alloy. Majority of the metallic substances used presently are in the form of alloys. The main intention behind this is to decrease the intensity of corrosion of metals. For example, bronze is an alloy formed from 90% copper and 10% tin. Bronze statues do not get affected by sun and rain. Stainless steel does not get stained with air or water and also does not rust. It is an alloy made from 74% iron, 18% chromium and 8% carbon. In recent times, various types of alloys are used for minting coins. Amalgam. Let us see what is an amalgam. When one of the metal in an alloy is mercury, the alloy is called amalgam. For example, sodium amalgam, zinc amalgam, etc. Silver amalgam was earlier used by dentists. Gold amalgam is used for extraction of gold.